Hello, students. I hope that my voice is loud and clear and everybody is listening. So, am I audible to all? Okay. So, in today's session, we will be seeing some more sets related PYQs. Okay. So, I want your full attention. Okay. So, moving on to the slides. Small disclaimer, the images, text and other materials used in our presentation are for educational purposes only. We respect the intellectual property rights of the original creators and owners. If you are the owner and have any concerns or issues, please contact us at sathee@itk.ac.in and we shall remove the content immediately. Please note that the part of the content may have been generated using a generative AI, which is an experimental. Now, here's our question. So simple, this question is related to NCERT section 1.9.3 and very simple question. Question says you are having three sets ABC such that a following condition that these three sets must be satisfying this condition. First of all, A intersection B must be non-empty and A intersection B must be subset of C. Then which of the following statement is not true? So 4 statements are given to you. You have to select which is not true. Option A says the intersection B intersection C is not empty. B says if A minus B is a subset of C, then is it always true that we are getting A is a subset of C? C says C union A intersection C union B is same as the set C. And D says if A minus C is a subset of B, if this going to be happen, then we having this always A is a subset of B. So just comment which one is not true. You'll have some seconds to try or start your approach, and then afterwards we will move on to the solution slide. So your time starts now. I hope the statement which is not true is D, which says that if A minus C is a subset of B, then A is a subset of B. This statement is not true. How? Let's see a solution. So we are going to check every statement. First says that intersection of B and C is not empty. Suppose according to the condition A intersection B is non-empty set. Yes. This gives me that there exists an element which belongs to the both set A as well as B. So we are having X such that X belongs to A intersection B. And because of this condition that A intersection B is a subset of C, so X also belongs to C. So what we are having is simply X belongs to A and X belongs to B. Also X belongs to C. Clear? Now, what I can conclude is that this X belongs to set B as well as in set C. So, I am having an element, at least an element which belongs to both set B and C. So, the intersection must be non-empty. So, first statement is true. So, second statement. If A minus B is a subset of C, is this always true? A is a subset of C. Yes. Why? Let me show you an example. So not an example, just a proof. So A minus B, what A minus B means? A set in which you have to collect elements which belongs to A but not in B. And we can write this set A into union of two disjoint sets. So first one is A minus B, second one is A intersection B. And from the statement condition, we are having A minus B as a subset of C, and from the question, we are having A intersection B as a subset of C. So then every element of A is in C. Every element of A is either belongs to set A minus B or in A intersection B. Both are the subsets of the set C. So the union of A minus B and A intersection B is same as the set A, which is also a subset of C. So we have showed A is a subset of C if A minus B is a subset of C. So the statement is also true. Clear? So moving on to next. Now the third. So C union A intersection C union B is same as C. We have to prove it or we have to give an counter example if it is not true. In this case, it is true. So we have to give a proof. So C union A intersection C union B can be rewritten in this form using distributive law. So C union A intersection B, and we know that this intersection is a subset of C. So what we are having is simply any set union with its subset is simply the set itself. So we are getting the right hand side as C. So in this case, this statement is also true. Now for the D part. So first three are true. The remaining one is indeed is going to be not true. So we have to provide an example. So A with 3 elements 1, 2, 3, B with 3 elements 2, 3, 4, C with 5 elements 1, 2, 3, 5, 6, and A intersection B is simply the set in which we are getting 2 elements 2 and 3. And this intersection is not non-empty and a subset of C, so satisfying the condition. Now statement says A minus C is a subset of B. Then are we getting A is a subset of B in every case? No. Why? Because A minus C is your empty set, as you can see. So you know that empty set is a subset for every set. So in this case, phi will be your subset for set B. This gives me A minus C is a subset of B. So satisfying the first condition of the statement, but not satisfying the second condition of this statement. So A is not a subset of B because one belongs to set A but not in set B. So D statement is not true. Clear? This question. In a certain town, the 25% of the population or families owns a phone. Simple. 15% owns a car. 65% neither owns a phone nor a car. And 2,000 families owns both a car as well as a phone. and you are provided with three statements A, B, C. A says 5% families owns both a car and a phone. B says 35% families owns either a car or a phone. And C says 40,000 families lives in the town. So you have to choose the option given to you, and the option must be correct. So first says both A and C statements are correct. B says B, C are correct. C says all the three statements are correct. And D says A and B are the correct statements. So please do try this problem. We will be providing you some time to understand the problem and try it. So then afterwards we will move to the solution slide. So your time starts now. Let us move to the solution slide. So now the correct option is C, which says that all the three statements provided to you are correct. Why? Let me show you a solution. So simply just assuming that NP represents the percentage of families that owns a phone, NC represents the percentage of family that own a car. Therefore, according to the question, the number of percentage or the percentage of families that owns a phone is 25% already given to us. And in case of a car, it is 15%. Now, what this 65 represent in terms of sets? Very simple. This represents neither a phone nor a car. So representation is simple. So P is a notation for phone and C for car. So not P means P complement and not C means C complement, meaning, and the intersection gives me neither phone nor car. Clear? Is this thing is clear? Now from this we can get P union C whole complement using De Morgan's law. Okay, so P union C whole complement is same as 65%, and if you recall, number of element in a complement is equals to what? Simple. Number of elements in universal set minus number of elements in the A set. Okay, so using the same thing, here universal set represent the 100%. So N of PUC is simply 100 minus 65, which is 35%. And inverse what this represents. Inverse what this represents. Very simple. P shows owns a phone, family owns a phone, and C shows owns a car. So what we are having is simply either families either owning a phone or a car. Now using this relationship, this formula, which says N of P intersection C is equals to N of P plus N of C minus N of P union C. We know N of P, we know N of C, we also know N P union C. So this gives me 5%. 5% is what? Families which owns both a phone as well as a car. Okay. So from here you can see that statement A is true. So 5% families owns both a phone as well as a car. Now let us assume that X families lives in the town, and we are given with that 2000 families owns both a car as well as a phone. So we know that 5% of this must be 2000. So from this we can get X as, or the population in the town is as a 40,000. So we are getting C also true, A also true. Now 35% meaning owns either a car or a phone, meaning union. So as you can see, P union C is simply 35%. So all the three statements are true. Okay. Now this question simply related to Venn diagram. So question says, in a school there are three types of games. Some students play two types of games, and but none plays all the three, meaning that we do not have a student which plays all the three games. Clear? So according to this given statement, which Venn diagram justifies the above statement? Simply you have to choose Venn diagram provided to you, PQR, which shows or justifies the above statement. Options P and Q both justifies this statement, or PR or QR, or none of the above. Simple. You'll have some seconds to try this problem, then afterwards we will move on to the solution slide. So your time starts now. So let us move to the solution slide. So answer, correct option is C, none of the above. Solution. So simply the shaded region of this Venn diagram represents the student who plays all the three types of games. So here this P, what P, if you observe P, in P this shaded area or region represents the student who plays all the three types of game. But what condition we are having is simply none of the students plays all the three games. So this is not going to be the best choice for the option, correct option. Okay. Now next, in Q, the shaded region of this Venn diagram represents the student who plays all the three types of games. So in Q also is not a best candidate for the correct option, as we are having from this Venn diagram, as we are having some student who plays all the three. And the R, again the shaded region of this Venn diagram represents the student who plays all the three of games. So simply in R also we are having common region which says what, that you are having some student which plays all the three games. Simple. As but in question, as none plays all the three games, so the intersection of all the three circles must be 0 or distinct. Hence none of the Venn diagram can justify the given statement. So option C is the correct option. This question, interesting question. So you are given with provided with this set builder form. So collection of all natural numbers such that the natural number must be greater than equals to 10 and less than equals to 100, also satisfying that 3 raised power n minus 3 is a multiple of 7. So this is your set builder form of your set, and you have to find out the number of elements in the set. Okay. You'll have some seconds to try this problem, then afterwards we will move on to the solution slide. So your time starts now. The correct answer or the number of element in the provided set is 15. How? Solution. So first of all, the given set, collection of all natural numbers satisfying n is greater than equals to 100, greater than equals to 10, less than equals to 100, and satisfying the condition 3 raised to power n minus 3 is a multiple of 3. How you are going to break this condition? Quite simple. So as given that 3 raised to power n minus 3 is a multiple of 7, this means I can write in this form that 3 raised to power n minus 3 is equals to 7 times some number, as it is a multiple of 7. So 7 times some number is some k belongs to some integer. Clear? Now I'm transferring this 3 to the right hand side, and the equation becomes 3 raised to power n is equals to 7k plus 3. Now my whole focus onto this equation, that for what values of n we are getting this to be true. Okay. For example, if you put n1, you will get 3 is equals to 7k plus 3, which is indeed true when k is 0. Clear? Now if you substitute n values one by one, this will be very lengthy process. So what we are going to use is mod concept. This mod simply used when we have to determine remainders. Yes. So let me just explain what this thing represent is very simple. If you divide this number, this left hand side number, to this number 7, then the remainder will be what? 3. So the remainder is written over here. So 3 is simply congruent to 3 mod 7. Clear? Now, so another, let me give you another example. Simple. 3 square is what? 9. If you divide 9 by 7, what will be your remainder? 2. Yes. So we are writing 2 here. This gives me 3 square is congruent to 2 mod 7, meaning when you divide 3 square, you will get what? 2 as your remainder. Okay. Now using this concept, what I can do is simply analyze the behavior of 3 raised to the power. Okay. Now 3 cube means 27. So divide by 7 will be what? Your 6 will be your remainder. So 3 cube is congruent to 6 mod 7. Now 3 raised to power 6 is simply congruent to 1. Meaning if you divide 3 raised to power 6 by 7, the remainder is simply 1. Now how this going to help me? Simply if you now 3 raised to power 7 is simple congruent to 3 mod 7. Okay. And from here and here, what you are getting is simply, so if you recall, you want n that 3 raised to the power n must be of the form 7k plus 3, or if you divide 3 raised to power n by 7, the remainder must be 3. So you are looking for the exponents of 3 in which you are getting the remainder 3. Yes. So in this manner I am going to use this concept. Okay, I am looking for those exponents of 3 which gives me a congruent to 3. Okay. So one is I am getting n as 1, n as 7, but I am looking for n greater than equals to 10. So next n will be what? So next n will be 13. So 3 raised to power 13 is congruent to 3 mod 7. Very simple. Okay. Now following the same pattern, what I can get is n is 13 and 19. So if you add 6 to every next consecutive number, you will get the next number. So adding 6 to the 13, you will get 19. Adding 19, you will get next 25 and so on till 97. As you are, you have to find out natural numbers less than equals to 100. Now simple, how many n values you are getting? Simply 15. So the number of elements, total number of elements in the provided set will be a 15. Clear?